Okay, so normally when we have a function, we are not giving point-by-point values like if x is 2, then the function's 5, or if x is 10, then the function's 13. It is more usual for us to give an algebraic function, something like these two, where function f takes whatever value you give it, doubles it, and adds 3, or function g squares the numbers it's given and then knocks off 1. So let's see if we can work with these effectively. There are two ways to do this, and I'm going to show them both. The first, when you're given an expression like f of g of 2, is to handle each function individually. So two separate steps. I'm going to take 2, plug that value into g. I'm going to take the result, plug that into f. So you start in the middle and dig your way out. If you do it that way, you're going to get, starting with g of 2, that's 2 squared minus 1, which is 4 take away 1 is 3. And then for the next step, we take 3 and plug it into function f. So f of 3 is, it'll be 2 times 3 plus 3. Everywhere there used to be an x, put a 3 instead. 2 times 3 is 6, plus another 3 is 9. So you can do the whole thing that way. The alternative, which is helpful if you're having to do this many times in a row, is to combine the two functions before you plug in any numbers. So when you see f of g, you think, okay, that means take function f and plug g into it. Here's how that looks. Function f of x says 2 times whatever x is plus 3. Now, what we're plugging into function f is this other function g. So instead of just having an x here, switch colors, we'll put the function g. And everywhere there used to be an x out here in the expression, instead we're going to put function g again, which is x squared minus 1. When I was learning these and found them complicated, this is how I do it. I would literally write x's in all these places and then erase it out and fill in the new function, and that takes some of the annoyingness out of it. Here you get f of g of x equals 2x squared minus 2 plus 3. And finally, f of g of x equals 2x squared plus 1. So this takes a little bit of work, but if you had to run off 5 or 10 values, plug them all into g and then into f, this is a more compact way to do it. And you can use it the same way you would any other function. You can take a 2, plug it in there, and you get f of g of 2 equals 2 times 2 squared plus 1. 2 squared is 4. Double that, you get 8. Add 1, and look at that, it works. So for a one-off question like this, would I recommend this method? Probably not. This is a little extra work that you don't really need. This method is very efficient. But if you have to assembly line this and do a whole bunch of the same calculation that's got two functions in it, then yes, it can save you time to combine them, get the resultant version cleaned up, and then you just have one function to use. It'll cut your work in half from there on. Let's see if we can make that work for B and C. I'll do those a little bit quicker. G of f of negative 1. If I do this one step at a time, I take negative 1 and plug it into f. F of negative 1 equals 2 times negative 1 plus 3 equals 1. I take that result and plug it into g. G of 1 equals 1 squared minus 1 equals 0. If I do it the other way where I combine the functions first, then I'm going to write function g. G of x for now equals x squared minus 1. Now, we're not plugging in simply x, we're plugging in function f. So we'll clear away those x's, and in their place goes f of x, and where the x used to be goes 2x plus 3. I apologize, that's a little small, but I trust you can follow. So 2x minus 3 squared is 4x squared plus 12x plus 9. You did remember to FOIL that, right? Of course you did. And that cleans up to 4x squared plus 12x plus 8. And now they request that we put negative 1 in there and see what happens. So g of f of negative 1 is going to be 4 times negative 1 squared plus 12 times negative 1 plus 8. That's 1 squared is 1 times 4 is 4. That's minus 12 plus 8 comes out to 0. It worked again. And last one, f of 3. If I do this as 2 steps, the first step is take 3, plug it into f. F of 3 equals 2 times 3 plus 3 equals 9. Second step, take that result, plug it into f again. Second pass, so 2 times 9 plus 3 equals 18 plus 3 is 21. Okay. Or, if we combine the functions, f of 3, here's function f of whatever equals 2 times whatever plus 3. And now the thing we're plugging in, the whatever, is not just an x, it is the function f again. So f of x, there we go. And the function is 2x plus 3, which we now get to clean up. f of x equals 4x plus 6 plus 3 equals 4x plus 9. And now they said the number you should be plugging into this is 3. So f of 3 equals 4 times 3 plus 9, which is 12 plus 9, which is, lo and behold, 21. So both ways work. This is the fast one, but this is the efficient one. Use this for a couple calculations. Use this if you ever have to do a page full.